Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone and welcome back. In this lecture, we are doing a project overview of our upcoming project, Backtesting Simple Moving Averages as a Trading Strategy. First, we'll discuss what is backtesting. Backtesting is a general method for seeing how well a strategy or model would do ex post, which means actual returns or after the fact. Backtesting assesses the viability of a trading strategy by discovering how it will play out with historical data. Simple moving averages is a trading strategy that we'll implement in this project. SMA calculates the average of a selected range of prices, usually the closing price of a stock, by the number of periods in that range. For example, you can use the previous 5 days if you have a window of 5 days for the simple moving average to predict the price today. The simple moving average is a technical indicator that can help you determine if an asset price will continue or if it will reverse a trend. We're going to use several libraries to help us in our project. VectorBT is one library that we will use. This is a Python package for quantitative analysis. VectorBT takes a new approach to backtesting, so it will be useful for our project. VectorBT operates entirely on pandas and NumPy objects, and it's accelerated by NumPy to analyze any data at speed and scale. As well, we're going to use the Kaleido library. This is a library for generating static images like PNGs, SVGs, PDFs, JPEGs, and it's a library for web-based visualization. So we're going to build visuals from our data and to predict our prices with our trading strategy. So a visualization library will come in handy for the project. All right, so that is an overview of our project. So join me coming up next where we're going to begin. Hello everyone and welcome back. In this lecture, we are beginning our project of backtesting simple moving averages, using that as a trading strategy. Our first step is going to be to load data for backtesting with VectorBT. VectorBT being a helper library. All right, so we need to use Yahoo Finance to get the data and VectorBT to load in the data. Yahoo Finance isn't the most exact data, but it is free and easy to get, so we're going to use Yahoo Finance. Join me at Google Colab in a new Colab. Here in a code cell, we're going to use the exclamation mark to access the console. Then we're going to use pip, which allows you to install packages with Python. We're using the install command to install the yfinance package. This is the Yahoo Finance package. As well, we're going to create a new code cell. We're going to again access pip and we're going to install VectorBT. Let's run that code cell. That's going to install the VectorBT package. Okay, then I'm going to import VectorBT into my Colab. And once it's installed, then you'll be able to access it. So then we can use VectorBT.yfdata. This stands for Yahoo Finance Data. We can use the download function to download data for a stock such as ETH/USD. We can then specify the frequency that we want a stock such as daily, as well as the fees 0.01. The missing index, we can choose what we want to do with missing indices. Let's drop missing indexes. And then we can specify what column we want to get, such as the close column. Then we can store this as our data. So let's run this code cell to download the data. And then once the download is complete, we can then paste out the data. So you can see we have several rows from 2017 to 2022. The frequency is daily. The name is close. and the length is 1596 rows. The data type is a float 64. All right, now we can select our time window that we want to use for our testing. If we, for example, wanted to specify only a certain year, well, in that case, we can take the data and use data.location, and then we could, for example, start at 2018 and finish at 2022. And then if you inspect the data now, you'll notice that we'll start at 2018. So you can restrict your dates like that. Okay, so that is our data. Now that we have the data, we can start building trading strategies with the data. So join me in the next lecture. We're going to build trading strategies with Vector BT. Hello everyone, and welcome back to backtesting simple moving averages as a trading strategy. Previously, we loaded our data for backtesting with simple moving averages with Yahoo Finance, and we installed Vector BT. In this lecture, we're going to build our trading strategies with Vector BT. So first, we're going to define our short and long simple moving average windows. Then we can test our different window combinations to see the results of buying and holding versus using a simple moving average strategy. Buying and holding is a passive investment strategy where you buy stocks and hold them for a long period of time, regardless of fluctuations. Whereas the simple moving average, this uses the average of a period of time before the current date in order to average out and predict what will be the next price. So let's start with a slow moving average. So I'm going to create here slow moving average and use my vector bt library.ma for moving average. And I'm going to use the run function, passing in my data and then passing in my moving average such as 20. Okay, then we can run this code cell and inspect our results once we have finished executing the code cell. So as a result, we get from vector bt indicators.basic moving average, an object of the slow moving average. Similarly, we can create a fast moving average with a different number of values that we're using, such as 10. So let's run that code cell as well. Then let's get our entries and exits. So for that, we'll create a new code cell and create an entries variable. We're going to take our fast moving average. You could also use slow moving average. And we'll use the function ma_above, which comes from vector bt. This is short for moving average above, and it's going to return true for every element where the moving average is above the value that you pass in here, slow moving average. So here we're comparing the two. We're going to return true where each element is going to be above this slow moving average, and then we can inspect our result by printing out entries or just pasting it out if you're on Colab. So here we get a new column added where we have false versus true. So those are our entries. We can also get our exits. So for that, we follow a similar process, but we are going to print our exits. And instead of using MA above, we use MA below, which is going to give you returning true for every element where the moving average is below the slow moving average. So you can print out your results here. All right, so that is going to be our trading strategy. We have a fast moving average versus a slow moving average. So next up, we can simulate a portfolio. So we can use vector BT's portfolio sublibrary to simulate a portfolio with our entry and exit signals. So these entries and exits, those are our signals for when we should enter versus exit our investment. So don't miss the next lecture. Hello everyone, and welcome back to backtesting simple moving averages as a trading strategy. Previously, we loaded our data with Vector BT and Yahoo Finance. We also built our trading strategies with Vector BT. In this lecture, we are going to simulate our portfolio with Vector BT. So we're going to fit a model and input starting investment to calculate the total profit from the trading strategy. So we can simulate a portfolio from entry and exit signals using vector BT. So I'm going to create a variable portfolio and use vector BT dot portfolio dot from signals, which allows you to simulate a portfolio. Here we pass in our data as well as our entries and our exits. We can also simulate our initial cash, such as 100. That is going to create the variable of portfolio, which we could print out. Let's wait a moment for the code cell to run, and then we can see the value of our portfolio dot from signals function. This will take the data, the entry point, and the exit points, and simulating that trading strategy. And remember, where did we get the entry and exit points? Well, we got them from our fast moving average compared to the slow moving average. All right, so our result is we get a portfolio object with the object details. We can get different properties from the portfolio, such as the total profit. So let's print out the value of our total profit using this trading strategy. Let's wait a moment for the code cell to run, and then we can check out our total profit. Okay, our total profit is 1,039.9. All right, so considering that we started with 100, that is a high profit. So that is our simple moving average strategy. But what about a buy and hold strategy? Let's compare the results. So let's simulate another portfolio, but this time, instead of using from signals, we're going to use from holding in order to simulate a strategy that is buy and hold. So I'm going to create a portfolio holding, and I'm going to use vector bt.portfolio, this time dot from holding, passing in my data, and my initial cash should be the same. Initially, I'll start with the same amount. Then we can print out our portfolio holding dot total profit. So let's run that code cell and let's simulate this trading strategy, and then we can compare the total profits between the two. Okay, so for buying and holding, we only profited 286.1. At least that's still profit, but it was not as much profit as the simple moving averages strategy. So we can see here that our strategy of simple moving average performed better in this case. Now, I would encourage you to try out on different lengths of time, because remember, we went from 2018 to 2022 if you look at your data. But you can try out with different periods of time to see how that affects your data, as well as with different stocks. Now, keep in mind, we're using historical data. So when you're using real data and you don't have historical data, you'll get different results. Otherwise, that is a comparison of our trading strategies. Don't miss the next lecture. We're going to visualize our results with the Kaleido package. So join me over there. Hello everyone, and welcome back to our project, Backtesting Simple Moving Averages as a Trading Strategy. Previously, we loaded our data for the strategy with Yahoo Finance. We built trading strategies with Vector BT, and we simulated a portfolio with Vector BT. In this lecture, we're going to use the Kaleido package to visualize a trading strategy. So join me back in your project, and we're going to use the command pip install Kaleido. This is going to install the Kaleido package for building visualizations, an alternative to Matplotlib or PyPlot. So let's give this a moment to install. Next, we can create a new code cell and take our portfolio and call the plot function to create a plot from the portfolio, and then call the show function to show that plot. So let's execute the code cell and await the results. All right, here we go. We can see our graph has been created. If you get an error message that Kaleido is not available, then you'll have to go to runtime and hit restart and run all. That way, sometimes when you install Kaleido on Colab, you have to restart the runtime. Otherwise, you should be able to see your results of your portfolio. So here, our first plot is the orders. We have our price on the y-axis, and we have the date on the x-axis. So we can see when we started out in 2018 with our data, and we can see that the price had somewhat of a plateau, a bit of a dip, and then it climbed high around the start of 2021, and it peaked and dipped, but then it climbed back and then dipped again, likely will climb back. And what about the trade P&L? Well, we have the trade P&L at the y-axis. We have then 0%, 50%, and 100%. And we can see here, for each point, we get the exit trade ID, the position ID, the exit timestamp, the P&L, and the return. All right, so if you have a positive P&L, you have a positive return or profit. As well, we have cumulative returns on the y-axis and the year or date on the x-axis in our final graph. So we saw that the returns were quite small, even negative, from 2018 to 2020, but starting in 2020, the returns started to grow and as well started to become profitable with our trading strategy. Right, so that is how you can visualize your portfolio results for your strategy simulator. You can also have a drawdown plot for a selected strategy. A drawdown refers to how much an investment is down from the peak before it recovers back to the peak. So we can create a new code cell and use our data.vector.bt.drawdowns and use the plot function. You can pass in a title here if you'd like, and then call the show function. And we just have to make sure our data has the vector bt object, so it actually is going to be VBT for short, for vector bt. Then run your code cell and you'll get another visualization. We have our title in the top left. We have lines for the closing, the peak, the valley, recovery or peak, and active. So we have on the y-axis from 0 to 5,000, and we have on the x-axis from 2018 to 2022, the length of our data set. And we can see that this trend follows a similar trend to our prices for the stock. So if I scroll back up, you can see that here the price versus the date had a very similar trend to the drawdowns. Right, so those are several visualizations that you can create thanks to Vector BT as well as Kaleido, two helper packages when working with portfolios and investments in Python. Don't miss the next section. We're going to start a new project. Hello everyone and welcome back. Coming up next, we are going to implement the Big 3 trading strategy on Binance Coin. We're going to use Python in Google Colab, as well as the Pandas library and the PyPlot library to build and visualize the strategy. But first, let's discuss what is the Big 3 trading strategy and how is it used to enter a trade, to day trade, to figure out when to buy, when to sell, when to enter, when to exit. First, you start with 3 simple moving averages. The most common periods used are 20, 40, and 80-day simple moving averages, but you can tweak this to try out different periods and see if you get better results, though the most common being 20, 40, and 80. Then you apply those 3 moving averages to your data. So you calculate the predicted price using each of the simple moving averages, and you can add it to your data frame. Next up, you can find the price trend. Is the price line, the line of the price of the stock, below or above the moving averages? If all 3 of the moving averages are below the price stock, that means the price is above them. So that predicts an uptrend because the price is above all 3 of the moving averages. As well, if the price line is below all 3 of the moving averages, this indicates a downtrend because the price is moving below the moving averages. So you can analyze what is the price trend. Next, you want to wait for the price close below the lowest moving average in a downtrend. If you have an uptrend, you want to wait for the price close above the highest moving average. Then you wait for the price to pull back and you move in direction of the trend to make your entry. So this would be one trading strategy that uses Big 3. So coming up next, we're going to take a look at how we can calculate and visualize a Big 3 trading strategy for a cryptocurrency stock with Python. Welcome back. In this lecture, we are starting our Big 3 trading strategy on a cryptocurrency. So join me in Google Colab at colab.research.google.com. First, we're going to load our data. So for that, we access the console with an exclamation mark, and we're using pip to install a package called yfinance. We can run this code cell, and once yfinance is installed, we can put it to use. yfinance is short for Yahoo Finance. So then we can import the yfinance package. All right, once we have imported it, we can put the package to use. So we can create our data by accessing yfinance and downloading some cryptocurrency or some stock. So for this, we're going to use the BNB-USD stock ticker for the Binance coin, and we're going to set a start date of 2014-01-01 and an end date of 2022-01-01. Then we can run this code cell, and that will download the data. So then we can inspect the data with the head function to check out some of the values. So these will give you the first 5 entries in the data frame. So it looks like our data set begins in 2017. All right, so now we have our data loaded, so we can create columns for a simple moving average of different numbers of days. So let's create in the data a new column called SMA, and we can start with 10 days. To create this simple moving average, we take the data at one of the columns, like the closing price, and we use the rolling function for a certain number of days. Then we can get the average. So if you run this code cell, you can inspect your data again, and this time you'll have an extra column. Note that for the first 9 days, you won't have a value for SMA because you don't have a previous 10 days. All right, so you can inspect the end with the tail function to see some of the simple moving average values. Let's create another column for simple moving average, and this time let's do 50 days. Let's run the code cell, and then we can inspect our data again. And now we have this second column, this time for the simple moving average with 50 days. And note that you have to change the rolling to 50 for this to work. There we go. Now the price is adjusted. Next, let's do one more for a simple moving average of 100 days. And then we can inspect our data frame again. And this time we see we have a third column added. Okay, so we have 3 columns for our different simple moving averages. Next up, we can visualize the results of these simple moving averages to figure out which one is the closest to the actual price. So for that, I'm going to create a new code cell, and I'm going to import matplotlib.pyplot as pyplot. This is a plotting library. Then we can create a figure and axes with pyplot.subplots, and we can pass in a figure size like 20 by 10. Then we can grab the axes and plot in using our data.index, starting with our data at the closing price. And we'll give this the label of the closing price. Then we can run this code cell, and we're going to see this graph created. On the y-axis, we have our price. On the x-axis, we have the date. So we can add a y-axis label by using axes.setYlabel, and we can call this the closing price. If you rerun the code cell, you'll have the y-axis label. If you want the label to be larger, then you can set the pyplot.rc_params.update, and you can update the font.size, for example, to 18. And if you do that before you plot, then it'll affect the font size of the whole graph. So if you rerun this code cell, okay, this time we should have our font size be larger. Okay, so I'm just going to move the line up to be even before the figure and the axes, and then rerun my code cell. And there we go. Now my text is larger. All right, now this is the actual returns. We want to compare the actual returns with our simple moving average results. So I'm going to call axes.plot again using my data.index. And then I'm going to grab the data at the SMA underscore 10 days for our simple moving average with a 10-day window. We can give this a label of our 10-day simple moving average. If you rerun the code cell, then you're going to see this new line added. And this is going to be orange, representing the 10-day simple moving average. If you want to add a legend, then you can call axes.legend and call that function. That way you'll have a legend at the top left-hand corner. Okay, let's do the other simple moving averages as well. We had 50. So we can add that to the graph. And we also had 100, so we can also add 100 to the graph. Then I will rerun the code cell. And here we go. So we can compare our results. So it looks like the 10-day simple moving average had the best results. The 50-day and the 100-day had poor results. You can adjust these simple moving averages to try out other window lengths, not just 10, 50, and 100, but other window lengths as well. All right, so this is how you can visualize your performance of your strategy from 2018 to 2022. Coming up next, we're going to take a look at how we can use our strategy on just 1 year. So don't miss the next lecture. Hello everyone and welcome back. In this lecture, we're going to learn how to build a Big 3 trading strategy on 1 year of stocks. So we're going to create a new variable called year data and use our data frame from 2021-01-01 up to the end of 2021, so 2021-12-31. Then we can take our year data and inspect the start of it to make sure we start at the correct point. As well, we can take our year data and inspect the end of it to make sure that we end at the correct point. Okay, so now we have a year's worth of data, and so we're going to visualize our simple moving averages on that year. So we can just take the code that we used previously for our Big 3 trading strategy and just paste it in again. So let's recap. First, we're using a pyplot, so we don't have to re-import it. We don't have to change the parameters either because those were already preset. We do have to create a new figure and axes. Right, and here we're going to create the pyplot subplots with our figure size. Then we're going to take our axes.plot, and instead of plotting the data, we want to plot the year data now. So replace every instance of data with year data. All right, so we're going to first plot the year data.index and the year data at the closing price. Then we're going to plot our year data.index against the 10-day simple moving average. Then we do the 50-day, and then we do the 100-day. All right, so we can rerun our code cell. And this time we have our visualization where we have on the y-axis the closing price of the stock. On the x-axis we have the day. So we go from 2021 to the end of 2021. And we have in blue our actual closing price. In orange we have our 10-day simple moving average. In green, we have the 50-day simple moving average, and in red, we have the 100-day simple moving average. So in this way, we can compare our moving average windows of different lengths. Right? So this is how you can take not the whole data set you have, but a specific data time frame like 1 year, and then compare your trading strategies on just that 1 year.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.